Assalamu alaikum, dear students. This is the lecture 2 of your course Structural Analysis 1. Now we will learn what is the determinacy of a structure and the stability of the structure. First one is the determinacy. The equilibrium equations provide both the necessary and the sufficient condition for equilibrium. As you have learned from your previous class about the equilibrium equations. Now, when all the forces in a structure can be determined strictly from these equations that are the equilibrium equations, then the structure is referred as statically determinate structure. Now, if the structure have more unknown forces then the available equilibrium equation, which are usually 3 in number as you have learned from your previous classes, then the structure is called a statically indeterminate. Now for a coplanar structure there are at most 3 equilibrium equations for each part, so that if there are total of n parts and r forces and moment reaction components, then the equation from which we can calculate the determinacy of a structure is given as R is equal to 3n, whereas you already know R is the force and the moment reaction components and n is the number of parts a structure have. If they are equal, then the structure is statically determinate. Now, if the force and the moment reaction component is greater than 3n, whereas n is the number of the parts, then the structure is statically indeterminate. Now, you will be able to understand this with an example which I will be showing you. Let's analyze a beam which has a roller support and a pinch support. It's overhang from the right hand side. Now how can we determine its determinacy? First of all, we have to draw the free body diagram of the same beam, which will be like this. For the roller support we have only vertical support reaction, let's denote it by by, and we have a pinned joint which you already know that it has a vertical support reaction ay as well as the horizontal support reaction which we can denote by ax. That means this beam has 3 support reactions which can be written as R is equal to 3, and we also know that n is equal to 1. It's only one part of the beam, so the reaction R is equal to 3n gives out 3 is equal to 3 multiplied by 1. That means 3 is equal to 3. This shows us that this structure is a statically determinate beam. Now example 2, which is also a beam it has 2 roller supports, one at the middle and one at the extreme left hand. Now we have another example. It has a fixed support at the left end and a roller support at the right end, and in between also at the center place it it has a roller support. Now if you will draw the free body diagram of the same figure, it will be like this. It has a support reaction CY, BY, and at the fixed end it will be having two translation support reactions and a moment. From this figure we can see that it has 1 2 3 4 and 5. It has 5 reaction components, 5 support reactions, and member is only 1. We have an equation which R is equal to 3n. That means R is 5 and 3 into 1 is 3. That means it has a difference of 2. So therefore we can write it, this structure or this beam or member beam is statically indeterminate by 2 degrees. One more example for the determinacy of the structure, which will make us quite clear with the concepts of how to analyze it in terms of the support reaction. We have a beam, it's fixed from one end, whereas it has a roller support at the extreme end, and it has a hinge at the center. Now from this beam, first we will calculate, first we will see what is the free body diagram. It will be like this. For roller support there will be a vertical reaction, support reaction at the roller end, and there will be a vertical translation at the extreme fixed end, which will be AY, AX, and a moment that will be MA. From this beam you can see we have a 4 number of support reactions. Does that mean this beam is statically indeterminate by 1 degree? No. That would have been the case if it does not have the internal hinge. This hinge does not make the structure determinate. With this hinge, if there is a hinge in any part of the beam, in such case we have to separate the two segments or the part of the structure, and then we have to analyze them separately. For the first part, which is AB, we have to see how many support reactions does it have, and how many support reactions does BN C segment have. From the free body diagram we can see that if we will separate the two parts of the beam, it will be like this. Now the second free body diagram would be, there will be two equal and opposite reaction components that are introduced at the hinge point. Now the total support reactions that you can see are 3 at the fixed end, 1 at the roller end, and 2 at the internal hinge. That means 3 and 2 6, 3 and 2 5, and 1 roller support is 6. That means R is equal to 6 and N is equal to 2. Therefore 6 is equal to 3 multiplied by 2, that is also equal to 6. This shows that the structure determinate. I hope it's clear now how to calculate the determinacy of the structure. Now we have the stability of a structure. Now what's it actually? The member must be properly held or constrained by their supports to ensure the proper stability of the structure. And the structure will be geometrically unstable, that is, it will move slightly or collapse if there are fewer reactive forces than equation of equilibrium, or if there are enough equations. Instability will occur if the line of action of the reactive force intersect at a common point or are parallel to one another. Now we can see if we have a coplanar structure, which we usually have. For such structures, we have a equation which, if r is less than 3n, then the structure is said to be unstable, or if r is greater than or equal to 3n, then the structure is said to be unstable, but if the reaction members are concurrent or parallel, or some of the components form a collapsible mechanism. Now we will try to learn how to categorize between the stable and the unstable structure by few examples, which are like. Now from these examples, be it a beam, truss or a frame, it can be viewed as a rigid body that's properly restrained by one or more supports. Such a system is said to be externally stable. From the first figure you can see we have a beam which has a pin support on the one side and the roller support on the other side. Same case, we have a truss, pin support on the one side and a roller support on the another side. And a frame element, a frame structure which has a fixed support at two ends and a roller support on the extreme end. There is no rigid body motion. Such a structure is statically stable. Now we consider a simple frame structure supported by two roller supports, which will be like it has two roller support on the both ends. If there is a load applied on the left side of the beam, the structure, this frame, will tend to move. It will tend to move. And if we apply this horizontal force, such as let's P, it will start rolling horizontally and the structure will undergo rigid body motion. Such a frame is externally unstable because it will never stop moving. And if we replace one of the roller support with the pinned support, if we replace one of the roller support with the pin support, it becomes externally stable. Now we have an example of truss. In this truss structure, you can see it's supported on a pin joint and a roller support, and there is a load at the point, let's say it's P. Now the support prevents any rigid body movement of the entire structure, but the truss is considered to be unstable because if we have localized the rigid body motion, then the structure is said to be internally unstable, which you can see from this diagram, the second diagram. And the structure is said to be stable only if it is neither externally nor internally stable. We will directly go to the equations which we have to consider while seeing whether the structure is a stable or an unstable structure. To determine if the structure is stable, we need to ask three questions. First one is, does there exist a loading pattern that makes equation summation of forces in x direction unequal to 0? Second, does there exist a loading pattern that makes equation summation of forces into y not equal to 0? And the third and the last equation is, does there exist a loading pattern that makes equation summation of moments in z direction which is not equal to 0? Now we will go to the requirements of a structure, what you need to see in a structure. As we have already seen, the requirements are of stability in a structure is of the utmost importance. Whereas we have other requirements also, which are like strength, serviceability, economy and aesthetics. Apart from these, we have the basic requirements of a structure, which are as follows. The first one is that the structure and all parts of it must be adequately stable under the action of external load in terms of the resistance to sliding, overturning, settlement, buckling, etc. Second one is the structure elements must be adequately strong, that is, the material strength must be greater than the stresses induced by the ultimate load. Third one is the structure elements must be adequately serviceable to ensure that they enable the structure to serve its intended purpose under normal service loads without excessive deflection, vibration, cracks, etc. That completes your first unit, and now you have an assignment, which is the question 1. What is the structural engineering, and describe the history of the structural engineering. Thank you.